My talk tonight was on Go, which is the most stupidly named language in the world. So Google, for some reason, decided to write a programming language called Go, which is the only term you can't really Google for. A little bit dumber than. So what I thought I'd do tonight is, because you're all not developers, I can make up shit about Go for about 15 minutes, and you don't know any different whether or not I'm right or wrong. But what I thought I'd do is I'd give you a very quick tour of the language, show you a little bit about what Go is about, talk a little bit about what I like in the language and what I don't like in the language, and hopefully whet your appetite a little bit to encourage some of you to go and have a look at it again. Given that a lot of you are front-end developers or designers, this is probably not the best language to pick because Go is a successor to C. It's designed as a systems programming language. It's designed to run on web servers or in the back end and do some heavy lifting for Google. It is kind of similar to C when you get started. It's syntactically kind of similar. There's some differences, but when you start off, you're like, oh, I kind of recognize what's going on if you come from C backgrounds. It's got pointers which are very similar to C. It uses them in a different way a little bit, but they're fundamentally the same kind of concept. And it's got a similar kind of set of fundamental data types. It's got sort of bytes, it's got arrays of bytes, it's got integers, floats, structs, those kind of things. All of that by default comes from C. Out of interest, how many people here are written C? Okay, cool. So enough that it makes sense to about half the room. That's kind of going, I guess. So Go is written by a team inside Google. It's written by a guy called Ross Pike, who came from Plan 9, which was a successor to Unix. So he's got kind of a very, let's say old-fashioned, but a very kind of Unix-based view of the world. Ken Thompson, one of the original authors of C, was also involved in this project. And the guy whose name I've forgotten but couldn't pronounce anyway, was also from Plan 9, was involved in this. So what they did is they set out to write a new language for Google, and they thought, you know, Google used a lot of C++, but these guys sat down and thought, well, what if we were writing C today, what would the language look like? So you have these carry-throughs from the original C programming language, but it's kind of different. It's kind of like a very modern take on C. It's definitely C under the core. Well, it's not C, but it's that kind of thinking. But they kind of applied 50 years of computer science to the language, and you get a lot of changes. So you get some new data types. You get slices, which are like arrays that can grow and shrink. You get maps as well, which are associative arrays. So you have keys and values. There's kind of a nod to functional programming. You can create first-class functions, so you can create a function and assign it to a variable, and I'll show you a quick example of that in a bit. It's got type inference. So in the code at Micro, for example, which is a Java derivative, which is in turn a C derivative or C++ derivative, you're writing things like int and then the variable name equals whatever. One of the things that Go does is it throws that way and says, if you say that, you know, my value called width is 20, I can work out that 20 is a particular type of value. It's an integer. So it can say, you don't have to explicitly tell me that this width is an integer because I can work it out from the assignment. You can't always work it out, but a lot of the time you can, and Go does that. I think a lot of the time Go is trying to take the way that C works and say, what can we chuck away? What can we do to make it a bit simpler? It's got garbage collection, which is great, because one of the big problems with C is memory management, which is a pain in the ass. If you're writing any kind of major C system, about half your code is going to be dealing with C, and about 120% of your support time is going to be dealing with memory allocation problems, or freeing up memory too quickly. One of the really interesting things about Go is it's built in concurrency. I'm going to talk about it a little bit, I'll show you a little bit of code, but it's kind of hard to demonstrate, it's small, but concurrency is like a first-class member of Go. It's really, really simple to take a function. I've got an example of a little example of a web crawler. And you can just say, run this, or run 2 of them, or run 10 of them, whatever, and they can talk amongst themselves, and you don't have to worry about creating threads, or worry so much about how they communicate to each other, or worry about like semaphores and mutexes to protect your memory. It's got concurrency built in from the very beginning. They took the C syntax, which I said in the previous slide, but they simplified it massively. This is kind of a pro and a con. It makes the compiler much simpler, which means it's much faster. One of the interesting things is that Go has appealed to a lot of people that are used to things like Python and Ruby and other interpreted languages, which is a bit weird for a compiled language. But the reason it does this is because it's simplified the syntax and because the toolchain is so fast, you can write a piece of Go code and run it, and it executes as quickly as your corresponding interpreted language would have done. So it's okay for prototyping it. A little bit hard to build up big systems like that, but you can start writing some code and say run it, and it's finished before you even thought about it. So because they simplified the syntax, they made stuff a lot easier the toolchain a lot easier to write, and subsequently a lot faster. And my favourite thing about this is there's no semicolons. This is like part of the syntax simplification is that they know where the end of the line is now, so they don't need to put semicolons in place.
How do you do compound statements then if you want simple ones? Okay.
Simpler syntax. So there's a lot of constructions which are valid in C which are not valid in Go, because they say, okay, no one uses them, we're just going to make it simpler, and then it makes it a lot easier for them and for everybody else. So that's the rethinking of C, but it's actually kind of an old language in some respects. They're very clear, people who Go are very clear that they were not writing a successor to C++. They didn't try and take C++ and fix it, or take C++ and write an equivalent system. So you don't have classes, you don't have a lot of the baggage that came from Smalltalk. There's no inheritance, there's no instantiating objects, that kind of thing. So it's not, if you come from an old background, you wouldn't look at Go and think, oh, this is an old language. But they took a lot of the core concepts, and what's interesting is if you play with Go for a while and you go back and watch some of the talks, Malvin Kay, the guy that wrote Smalltalk originally, and was the guy that coined the term object-oriented. If you look at what he was saying is the way that object-oriented programming should work, as opposed to looking at things like Java and C++ and I guess C# and things that have come from that background, you do have a lot of the underlying ideas in Go, but you don't have the same syntactic structures around it. So you don't have classes, you don't have a very strong class-based, inheritance-based type system. But what you do have is a couple of things. One is that you can, I haven't written a slide here, I think, you can take a piece of data and you can attach methods to it. So you can say, I'll show you an example in a little bit, but you can take a structure and say, this is like a person object that's got a first name and a last name, which is a little bit like your fields in a classical oral language. And then you can put methods on top of that. So it feels a little bit like oral programming. The other thing it does, which I think is much closer to Alan Kay's original thinking, is it gives you this concept of interfaces. And they're a little bit like, so how many people here know Java? A little bit? Not that many. Okay, cool. So it's a little bit like a language you don't really know. It gives you this idea of interfaces, and when you specify an interface, you're saying this piece of data that I'm going to pass around responds to these methods. These are the methods that you can call on this piece of data. Unlike Java, you don't have to explicitly say, and this class implements them. What you need to do is say, when I take an object in, or when I take a piece of data in, these are the things that I expect it to do. And that's what an interface is. It's called structural typing. And interesting, you're reading the Go stuff, people get very het up about the right terminology for this. I believe structural typing is the correct term, but Go people would argue for days about this. But what it does is it says, it puts the emphasis back on the communication between objects. So rather than saying, I have something and it's a person type, it doesn't really care about that. What it does is it says, when you give me a piece of data, I expect to be able to call first name on it, or last name, or whatever else. Okay, so it's saying, when you give me something, these are the things that I can do with that piece of data, with that object, in a sense. Okay, so that's my kind of crash course on what Go is. I kind of apologize for this. I wrote this in a hurry, so the next few slides are going to be very code heavy. But I thought I'd give you some examples and show you a little bit about what Go looks like, and then when we're looking at the code, we can kind of point out some of the interesting things about the language. I thought I'd start with first-class functions because I can show you a few different things with this. So here I'm declaring a variable called mult, and I'm saying that it is a function. So whenever I use this variable, what I'm really doing is calling the function. And here I'm saying it's a function which takes two integers called x and y here, and it returns a different integer. Okay? So the stuff that's in yellow is keywords from the syntax. The syntax from Go is really, it's even smaller than C, it's really very tiny. The stuff in blue is the built-in native types inside Go. So I've got my variable now called mult. So what can we do with that? A little bit complex, but what I can do is find another function called p. And what that does is it takes a function as one of the arguments. It takes two arguments, x and y, as integers. It actually takes b1 and b2, I've got to read them all. Pretend the first two things say b1, b2, integers. But the third argument it takes is something that assigns to a variable called fn, which is itself a function. And that function has got a particular signature. It takes two integers and returns another integer. Yeah? And all that p does is it prints out, you passed in these two values, and this is the return you get from calling the third function. So what we can then do is we can call p, but what we can pass into p is the function we defined at the very beginning. Okay. This is quite nice, and I'll show you an example again when we get to concurrency, but it's quite nice that you can take a function, store it in a variable, and then pass that around and say, okay, now use this function to do some piece of work for you. Yep. The colon equals, incidentally at the top, is this type inference assignment thing. What you're doing is you're saying, I have a new variable called mult, it doesn't exist anywhere before in the program. I'm going to assign it to a new value, and work out yourself what the type of that is. And it works out, because you said equals func x, y, int, it works out that what you have is something that takes two integer values and returns an int. That's the type of mult. Yeah, and the same for p. So when you pass mult into p, it says, okay, mult matches the argument type that we're expecting, which is a function which takes two integers and returns an integer. I thought I'd show you methods a little bit. Sorry for all the code here, but the first thing we do here is we define a new type. And I've called it person, and it's just a struct type. And a struct type, for those of you who haven't got C background, is something which has got a number of different fields, and each of those fields has got a type. So here we have a structure which contains two elements, first name and last name, and they're both strings. But where Go kind of breaks off from C and goes in its own direction is this next line where we say, I'm going to define a new method called full name, but I'm going to define it on a particular type. And the type here is a person, in fact it's a pointer to the person. And that method called full name takes no arguments but returns a string. But suddenly inside the method we have access to p, which is a person object. So you call the method on the person object, and we've got access to all the stuff inside the struct. Now you don't have to declare on the struct, it can be any type at all you want. So I've done stuff where I've created arrays. I've said type, it's a list of URLs, it was an array, and define new methods on top of that. But you can take any native type in Go, you can declare a new type on top of it, and then define methods on top of that data. So what I've done next is I've defined a variable called John, and I've said it's a new person object, a new person struct. I've filled in the details of the two fields it's expecting, and then I've called a method on John, which is this full name method. So when you call full name, John gets assigned to p, and then you have access to the fields inside John. So this is how it works. Couple of scary things in this slide. This ampersand. This is where C's inheritance really comes through. So you're not actually storing the person structure inside John. What you're doing is putting John somewhere in memory, and you're storing a reference to it. You're saying, whenever I say John, follow this link, and then have another piece of memory. What it really means is, when I call this full name method, I don't have to take John, the data and copy it byte for byte, and then execute a method on it. What you can do is you just hit a pointer to the actual data you want, and then execute it in that. So it's more efficient, but it also means you can update the fields inside the object that you're calling. These curly braces as well mean we're going to allocate some new memory. So in C, you'd have to say explicitly, I'm going to create some new memory, and it's going to be this long, and this is the stuff I'm going to put inside it. Here you just say, open curly brackets after the type. So you've got person, which is the type, and then open curly brackets, and you just fill in the data, and it does the allocation for you. Okay. So under the hood, or certainly from the genesis of Go, it's got this C-like thinking about you have pointers, you've got memory allocation, you've got whatever else. All it's tried to do is make it much simpler. So you can get the same efficiency, or a similar kind of efficiency you can get out of C, without all of the syntactic baggage and having to write hundreds of lines of code just to do a very simple thing. Very quick overview of concurrency. So here I've defined a function called crawler. Again, we use our the FN should say func, sorry. I'm creating a crawler, which is a new function which takes a string in, which is the URL we want to crawl, and it returns another string, which is page contents. And I've left out the details of how it works. But for concurrency, what you can do is you can create two processes which run kind of side by side. You can schedule by the Go virtual machine. One which is calling Google, and one which is calling Apple. And you don't have to wait for the Google crawler to finish before you run the Apple one. What the virtual machine will do for you is it'll send a request to Google, and while it's waiting, it'll run the one for Apple. And as the responses come back in, it'll start reading the data back in, and then it will return in whatever it would feel like. So you just say, you get a function which does something, you just put the word go in front of it. It's kind of like firing from a thread and runs off and does it for you separately. It's not exactly like that, but it gives you the same kind of effect. Very cool. It's built right into the language, so a lot of concurrencies are very simple in Go, whereas it would have been very complex in languages like Java. It's like in C#, but I'm guessing it's kind of hard, it's thread-based. Okay. Certainly a lot easier than sort of the C origins that it comes from. To go with concurrency, there's the idea of channels. So you've got two crawlers, and they're independent, and that's fine, they can just go off and run, but how do you share data between the two of them? And what Go has is this concept of channels. So I've created my crawler again, but instead of taking a URL string argument, what it takes is a channel, and the channel is a channel of string types. And all it does is it sits there, looping forever, and waiting until you send something in on that channel. So that arrow pointing in from the URLs says, I'm going to read a value off the channel, and that blocks until there's some data available. So when we say Go crawler with that channel, what it does is it runs that infinite loop, gets to select, and stops until there's some data available. And then we send Google.com into the channel, and the crawler that we're running will read that off the channel and go off and do its thing and download the content and do whatever you want with it. And then we send Apple.com in, and in this case it'll lock, actually. It'll wait until the channel's free. You can create a channel with a buffer, in which case it would just get stored in the buffer, and then wait until someone consumes it. So what you do is you have two separate processes running. One is the main process here, and the other one is one we started by saying Go crawler. They both share a channel. One is putting data onto it, and the other one's reading out. And you have to worry about synchronizing them, or making sure that the memory access is atomic or guarded by mutexes or whatever. You just use these channels and put data in and read data off. So it makes concurrency and concurrent processes communicating very simple. Not as simple as Erlang makes it, but still pretty simple. So that's my whirlwind tour of Go. Hopefully give you kind of a flavour of the language. I thought I'd talk a little bit about what it's like to use. So it's designed as a systems language to replace stuff you typically write in C. Bizarrely, it got picked up by the Python community big time. A lot of Python developers have moved to it. I think that's because a lot of the Python developers work for Google, and Google was kind of forcing the language. But it's it's kind of interesting that it's appealed much more to the kind of interpretive language, scripting language community than it has done to the C++ community.